हेलो दोस्तों एंड वेलकम। आज के इस डीप डाइव एक्सप्लेनर में थिंक ऑफ मी एज योर बड़े भैया और दीदी, क्योंकि आज हम फिजिक्स के एब्सोल्यूट फंडामेंटल्स को बिल्कुल ब्रेक डाउन करने वाले हैं। वी आर मास्टरिंग किनेमैटिक्स, फोकसिंग प्योरली ऑन मोशन। नो फियर, नो स्ट्रेस, जस्ट प्योर लॉजिक और कुछ बहुत ही कूल रियल वर्ल्ड एग्जाम्पल्स। तो चलिए लेट्स डाइव राइट इन।
Here's our roadmap for today's session. हम शुरू करेंगे डिस्टेंस और डिस्प्लेसमेंट से, then we'll move into speed, velocity और acceleration. उसके बाद we'll tackle the equations of motion, followed by graphical proofs का जादू. And finally, we'll wrap up by solving some actual real-world problems.
Alright, kicking things off with section 1, distance or displacement, let's understand the path.
So सबसे crucial point ये है कि physics में distance और displacement are completely different beasts. Distance is simply the total path you've covered. ये एक scalar quantity है, meaning it only cares about the how much. Displacement, on the other hand, is the shortest straight line path from your initial position to your final position. ये एक vector quantity है, जिसका सीधा सा मतलब है it strictly cares about direction. अगर आप direction change करते हो ना, your displacement immediately changes, even if your total distance just keeps adding up. इस कॉन्सेप्ट को हमेशा के लिए दिमाग में लॉक करने के लिए जस्ट रिमेंबर दिस सिंपल गोल्डन रूल फ्रॉम आवर नोट्स। कितना चला इक्वल्स डिस्टेंस, कहाँ पहुंचा इक्वल्स डिस्प्लेसमेंट। लिटरली हाउ मच यू वॉक्ड इज योर डिस्टेंस और एग्जैक्टली वेयर यू एंडेड अप रिलेटिव टू वेयर यू स्टार्टेड, दैट इज योर डिस्प्लेसमेंट। कीप दिस सिंपल मंत्रा इन योर हेड और आप फाउंडेशन लेवल का कोई भी क्वेश्चन कभी गलत नहीं करोगे।
एंड दिस विजुअल ब्रिलियंटली इलिस्ट्रेट्स दैट एग्जैक्ट मंत्रा। Notice that crazy squiggly yellow line winding all over the place? That's your distance. हर एक step जो आपने लिया, that is your कितना चला. But look at that straight blue line cutting right across the bottom. That is your displacement. It just connects the start directly to the end. It's simply your कहाँ पहुंचा. Makes sense, right?
Moving right along to section 2, speed, velocity or acceleration. Let's see what happens when we change positions fast.
So, velocity is basically just speed but with a specific direction. पर सोचो क्या होता है जब आपकी velocity change होती है? Well, that brings us to acceleration. अगर आपकी velocity uniformly increase हो रही है, then you're accelerating. मतलब आप literally gas pedal दबा रहे हो. But what if you press the brakes? आपकी velocity decrease होती है. Physics में we actually call this retardation, which is simply just negative acceleration.
Let's see how easily we can actually calculate that retardation. यहाँ we have a train that's slowing down. Its initial velocity, जिसे हम u बोलते हैं, is 30 meters per second, and it drops down to a final velocity, v, of 10 meters per second. And it does all this in just 5 seconds. So using the formula a equals v minus u over t, we get 10 minus 30 divided by 5. That's minus 20 over 5, giving us an acceleration of minus 4 meters per second squared. Notice that negative sign? Exactly. It's telling us it's retardation. The train is definitely hitting the brakes.
Chalo, let's test you with a classic trick question. Imagine Usha swims in a 90-meter long pool. She goes from one end to the exact other end and then comes back along the exact same straight path in 1 minute. So I'm asking you, what is our average speed and what is our average velocity? Think really carefully about our kitna chala versus kahan pahuncha rule.
Did you catch the trick there? Let's break it down together. Her total distance is 90 meters there plus 90 meters back, making it 180 meters total in 60 seconds. Since average speed is total distance over total time, we do 180 over 60, giving us a speed of 3 meters per second. But wait, because she came right back to her exact starting point, her displacement is literally zero. Jiska matlab hai, her average velocity is exactly zero. Even though she was swimming super fast, her overall change in position was absolutely nothing.
All right, we've reached the boss level. Section 3, equations of motion. Let's look at the big 3 tools.
Behold the big 3 equations of motion. V equals u plus at, s equals ut plus half at squared, and v squared equals u squared plus 2as. I know, at first glance, ये equations देख के थोड़ा डर लग सकता है, but I want you to shift your perspective entirely. Think of them not just as formulas, but as magic tools. They literally let you predict the future. They tell you exactly when a speeding car is going to stop or exactly how fast a ball is moving right before it smacks the ground.
Next up is section 4, graphical proofs kajadu. This is where geometry beautifully meets physics.
तो चलिए पहली इक्वेशन डिराइव करते हैं। If you look at this velocity time graph, the vertical y-axis represents velocity or horizontal x-axis represents time. The slope of this line is actually our acceleration. And how do we find the slope? It's just the change in the y-axis over the change in the x-axis. So, v minus u divided by time t equals our acceleration a. With just a tiny bit of algebra, multiply by t, move the u over, bam, you get v equals u plus at. It's literally just the visual definition of acceleration.
अब displacement का क्या करें, which we represent with the letter S? Well, the magical rule of a velocity time graph is कि the total area under the line equals your displacement. इसको easily find out करने के लिए we can split this shape into two distinct parts. एक rectangle at the bottom और एक triangle on top. The area of the rectangle is u times t. The area of the triangle is half base times height, so half times t times v minus u. Now, substitute at for that v minus u, or perfectly, we get our second equation. S equals ut plus half at squared. See, it's pure geometry.
To wrap up this graphical magic, let's derive the third equation. Instead of splitting the shape like we just did, what if we calculate the area of the entire shape as one single trapezium? The standard formula for the area of a trapezium is half the sum of parallel sides times the height. So, S equals half times v plus u multiplied by t. Substitute t from our very first equation, and as the algebraic dust settles, it beautifully gives us v squared equals u squared plus 2as. The math completely and perfectly aligns with the visual geometry.
Finally, Section 5. Solving real-world problems. Let's apply these magic tools to some fun scenarios. Picture this dramatic scene. Champa is out for a nice stroll, starting from rest. Suddenly, she spots a snake. Panic sets in, and she accelerates away at a whopping 4 meters per second squared over a distance of 100 meters. The question is, what is her final velocity when she reaches that 100-meter mark? Okay, here is the absolute secret cheat code to solving literally any physics problem. Hamesha sabse pehle apna data organize karo. What exactly do we know? Initial velocity, u, is 0 because she started from rest. Acceleration a is 4. Displacement s is 100, and what are we looking for? Her final velocity, v. Notice we don't know the time, and honestly, we don't even care about the time. So which of our three equations fits this setup perfectly?
Yes, you guessed it, the third one, v squared equals u squared plus 2as. We just plug in our neatly organized data. V squared equals 0 squared plus 2 times 4 times 100. That means v squared equals 800. Take the square root of that, and boom, Champa is zooming away at a final velocity of 20 root 2 meters per second. Structured data in, perfect answer out. So simple.
Now let's take a quick trip back in time. This is a genuinely fascinating problem from ancient India. Two postmen start walking towards each other from a distance of 210 yojanas. One travels 9 yojanas a day, and the other covers 5 yojanas a day. Since they are moving directly towards each other, unki relative speed adds up. 9 plus 5 equals 14 yojanas a day together. Take the total distance of 210, divide it by their combined speed of 14, and you'll find they will meet in exactly 15 days. Whether you're measuring in modern meters or ancient yojanas, these fundamental rules of motion remain completely universal.
And that brings us to the ultimate question for you to ponder today. We just used these concepts to track Usha in a swimming pool or Champa ko running from a snake. But remember, these exact same kinematic principles, distance, displacement, velocity, and these three amazing equations of motion are the foundational building blocks that scientists at ISRO and NASA use to calculate the trajectories of rockets. तो अगली बार जब आप आसमान में एक रॉकेट को लॉन्च होते देखें, ask yourself, which of these equations of motion is driving it upwards right now? Keep exploring, keep questioning, and I'll catch you in the next explainer.